Hi, welcome to my video on rational functions, and this video is going to look at the function f of x equals ax plus b divided by bx plus d and on k. A, b, c, d, and k belong to the real numbers. So, in the previous rational functions and the videos we did, we looked at 1 over x. We looked at 1 over x squared. We also looked at 1 over x minus 1, x minus 2, and we also looked at rational functions which has an x plus 1 over x plus 3, x minus 4. And if you notice, all of these have the degree in the denominator larger than the degree in the numerator. The degree here is 1, degree here is 0, degree here is 2, 0. Degree here in the bottom is x squared, which is a 2, and this is a 0. And this one has x squared, degree 2, and this is an x degree 1. So, and what happens in each of these functions as x approaches infinity or negative infinity, then the function f of x approaches 0. But in this video, let's look at these examples. There's 3 examples, and in these examples that's going to be in this video, we're going to look at, notice that the degree of this numerator is 1, degree of this denominator is 1. So that means as x, if we let x go to infinity, we get y is equal to x plus 1, let's say is infinity, plus 1 over infinity plus minus 3. So as this numerator gets large and its denominator gets large, adding 1 and subtracting 3 is not going to make any difference. So that means y, the horizontal asymptote, is going to be a 1. And this is similar here. Again, the degree is 1, degree is 1. The degree of the numerator and denominator are the same. So as y equals, so we get 4 times infinity, and the minus 2 is not going to affect it, and going to infinity, that means the asymptote is going to be a 4. If we cancel the infinities out, this is my quick way or fast way of recognizing this. And here we have, again, the degree of this is 1, degree here of is 1. So we have infinity being divided by 2 times infinity. If we cancel out, that means the horizontal asymptote is y equals a half. And again, I want to remind, in this video, the numerator and the denominator of each of these are linear polynomials of degree 1. Let's continue. Let's do some examples of this rational function. So we have f of x equals x plus 3 over x minus 2. So let's change the f of x to a y, as we've done in all the other videos. And we have a plus 0. Plus 0 means that we can look at that we have a horizontal asymptote is at 0. And what other one? Well, the vertical asymptote is when you let your denominator equal to 0. So that means the vertical asymptote is x equals 2. So that's vertical asymptote. Remember, the graph will not pass through this vertical asymptote of x equals 2. It'll go along by, like go up here, or go down here, or it can go up here, or it can go down here, but it will not pass through this vertical asymptote. So also let's look at the horizontal asymptote. And the horizontal asymptote, as x approaches infinity, or as x approaches negative infinity, so the horizontal asymptote is, we have y equals if it goes to infinity, x into infinity here and x to infinity here, that means the horizontal asymptote is y equals 1. And the horizontal asymptote, there's 2 there, so 1 is right to the middle here. So this is the horizontal asymptote. So y equals 1. So we have a vertical asymptote and a horizontal asymptote. So that means as x goes to infinity, it'll go towards 1 here, or as x goes to infinity, it can go towards 1 here. So let's do more work to see what we have. So let's look at the y-intercept of this graph. So the y-intercept is when we let x equals 0. So we got y equals, take this equation, put a 0 in. 0 plus 3 over 0 minus 2. So that means that y equals 3 over negative 2, which is a negative 3 over 2. So that means when x is 0, y is negative 3 over 2, or negative 1.5. So there's negative 1. So negative, when x equals 0, which is here, y is negative 1.5. So let's take that point to be right there. So that's 0, negative 3 over 2. So now that we found a y-intercept, does it have an x-intercept? So the x-intercept is when we let y equals 0. So take this equation and put 0 in for y and write down the remaining part of the equation. So we can do this 2 ways. We can either put it over 1 and cross multiply. So 1 times x plus 3 is x plus 3. 0 times x minus 2 is 0. So x is negative 3. So the x-intercept is x is negative 3 when y is 0. So x is negative 3 when y is 0. So that's this point right here. So this is the point of negative 3 comma 0. And another way to do this, in this equation, if y is equal to 0, that means if this is a fraction, that means your numerator must have to be 0. So x plus 3 is equal to 0 because, again, y is 0 if the numerator is 0. So if x plus 3 is equal to 0, then same as here, we got a negative 3. So there's 2 ways to do it. Put it over 1 or let your numerator equal 0 and solve it. Now, we have this point and we have this point. So we have to go and find some more points. Again, if it's passing through here, so it's a horizontal asymptote, as it goes to negative infinity, you got to go this way. So it has to come over here, and so it's hitting here and here. So it looks like it's coming up through here like this, and that means we'll check. So let's look at some other points on this. So we got x and y. So we have let's look over here. So we got a vertical asymptote at 2. So let's look at 3. What's 3 going to give me into this equation? So I'm going to take a 3, x equals 3, and sub it into y equals x plus 3 over x minus 2. So x is 3 plus 3 over 3 minus 2. That's 6 over 1, or 6. So when x is 3, y is 6. When x is 3, y is 6. So that's this point here. So that means it can't go this way. It can't go like this towards this asymptote. So it has to go up here and come down through this point and go along by the horizontal asymptote. So that's now. What about on the other side of this vertical asymptote? So let's look at the other side. We could take another point on this side. We could look at another point just to make sure, if you wish. So let's look at the 4. So when x is 4. So when x is 4, just to make sure, because x is 4, so we put a 4 in, we get a 7 over 2, or we get, so when x is 4 right here, we get 7 over 2, so 7 over 2 is 3.5. When x is 4 right here, that's 2, 3, 4, we get 3.5. So let's say that's about there, so we can see it swing this way. So this one, again, goes through here and here towards this, so it can't go this way, so it has to come out through here, down towards the vertical asymptote like that. And as x goes to infinity, then the value of y goes towards 1. So there's the graph that represents this rational function. Okay, let's look at another one. The more we look at, the better idea we get. So now we have f of x equals 2x minus 1 over x plus 1. And again, you can see that the horizontal asymptote, because these both of them have degree 1, then the horizontal asymptote is going to be 2, because this is a plus 0. So f of x is a y, so we got 2x minus 1 over x plus 1, and on 0. So let's look at the vertical asymptote. So the vertical asymptote is when your denominator is equal to 0. So let x plus 1 equal 0, x is negative 1. And the horizontal asymptote, as x goes to infinity or negative infinity, that means that y, so look at the equation, let's look at this right here. So I'm going to infinity, so that's 2 times infinity over infinity. So notice subtracting 1 or adding 1 to infinity is minute, it's not going to change the value. So that means the horizontal asymptote is y equals 2. So the vertical asymptote is x equals negative 1. So the graph will never cut through a vertical asymptote because the fraction cannot have 0 in the denominator. So negative 1 is x equals negative 1 is the vertical asymptote. Horizontal asymptote is 2. So 2 is here. Horizontal is right here. And that's y equals 2. Now, where does the graph go? Again, the vertical asymptote, so the graph is either going up here like this, or it's like this, or it's down here, going along like this, or it's like this. Let's find out where it goes. Let's look at the y-intercept. The y-intercept is when you let x equal 0. Take the equation, so y equals 2 times 0 minus 1, and 0 plus 1. So 2 times 0 is 0, so we get a negative 1 over 1. So the y-intercept is, and that's the point when x is 0, negative 1. X is 0 right here, and y is negative 1, so that's this point here. So it's 0, negative 1, so it's going through here. So it's either going up like this, or it's going here, but it has to go along by, so it looks like it's going to go, as x goes to infinity, y approaches 2, so it looks like it's going to go this way, like this. But we'll check it out further. Let's look at the x-intercept. The x-intercept is when you let y equals 0 into this equation. So we get 0 equals 2x minus 1 over x plus 1. And again, we can put it over 1 and cross multiply, or we can have our 2x minus 1 equals 0 because it's the numerator of a fraction. In order to get 0, the numerator is equal to 0. So we can go 2x minus 1 is going to equal 0. 2x is equal to 1. Divided by 2x is a half. So this is the point. Y is 0 and x is a half. So x is a half and y is 0. So that's right here. So that's that point there. X is a half, y is 0. So we can see that it's going this way. So as x goes to infinity, y is approaching 2. And it comes down along here as x approaches negative 1, y is going to negative infinity. Okay, what about on this side? Is it here or is it up here? So is it doing this or is it doing this? So let's check and let's do a table of values. And this is -1, so let's look at -2. So let's put a -2 into this equation. So x equals -2, and we're going to use the equation 2x, which is what we have. So this is the equation, and we're going to put -2 in. So 2 times -2 minus 1, -2 plus 1. So that's -4 minus 1 is -5 over -1. So that's a 5. So 2 gives us a 5. So the ordered pair is 2, -2, comma 5. X is -2, comma 5. And that's right here. That's -1, -2. So that's that point there. So that point is -2, 5. So it looks like it's going to taper this way. But just check. Let's do another value of x. Let's take the value of x to be 3. And put 3 in. X is, -3 in, because we're going on this side. So y equals 2x minus 1, x plus 1. So we're putting a -3 in. So a -3 in the place of x. -3 is in the place of x. -6 minus 1 is -7. -2. So that gives us 7 over 2, or 3.5. Let's see. So the point is x is -3 and 3.5. X is -3 and 3 is here. So 3.5 probably just estimated to be right here. So we can see there's the graph. So as x goes to negative infinity, y is going to 2. As x goes to infinity, as x goes to -1 on the left side, y is going to positive infinity. Remember, it can't cut through the vertical asymptote, so it goes, the closer and closer you get to -1, the closer and closer it gets to x equals. So the closer I get here, this goes higher, and it's getting close to the -1, but it's going to infinity on this side, and it's going to negative infinity on this side. Okay, let's try one more. One more to do. Here we go. Graph this one. Notice this time we have a -3. So we have y equals x minus 2, x plus 3, minus 3. And let's see what we have. Let's look at, I always do, I look at the vertical asymptote first. So that's when your denominator is equal to 0. You can't have a denominator 0, it gives you vertical asymptote. So the vertical asymptote is x equals -3. 0, -1, -2, -3. So it's straight down. Remember, it will never cut through a vertical asymptote. So it either goes again like this, or like this, or it goes here like this, or like this. So we'll continue. What about the horizontal asymptote? As x approaches infinity or negative infinity, let's see, we have this equation. We got y, and infinity minus 2 is the same as infinity. Infinity plus 3 is the same as infinity minus 3. So when you take infinity and divide it by infinity, so if you take a million divided by a million, you get 1. If you take a billion divided by a billion, you get 1. So that's 1 minus 3, which is -2. So the horizontal asymptote is y equals -2, which is right here. There it is. So now the makings of the graph is doing this, or it's doing this, or it's here, or it's down here. Again, as x goes to infinity, then we have to approach it. So it comes down, so it's either here, as x goes to infinity on this, if it's down here, as x goes to infinity, it goes here. So there it is. So let's look at the y-intercept when x is equal to 0. So we take the equation, y equals, we're putting a 0 in here, 0 minus 2 over 0 plus 3 minus 3. So that gives us negative 2 over 3 minus 3. So that gives us a negative 3 2/3. So when x is 0, negative 3 2/3. So the y-intercept is negative 3 2/3. There's negative 3 2/3. Let's take it roughly to be here. So that's x is 0, negative 3 2/3. So that means it should be looking like this. Okay. Now, I found a y-intercept. Let's find the x-intercept. The x-intercept is when you let y equal 0. So take this equation and put 0 in the place of y. 0 equals x minus 2 over x plus 3 minus 3. So we have to solve this equation. So one of the fast ways I solve it is multiplying. Now I could multiply by, so I could multiply by x plus 3 because it's a fraction. Or I could just take the 3 and move it to the left, make it positive, over. So move the 3 over, put it over 1, cross multiply. So 3 times x plus 3 is 3x plus 9. 1 times x minus 2 is x minus 2. So that's 3x minus x equals negative 2 minus 9. 2x is negative 11. X is negative 11 over 2, which is a negative 5.5. So this point is x is negative 5.5 when y is 0. So x is negative 5.5 when y is 0. So that's negative 6 there. So there it is right there. So this point is negative 5.5 comma 0. So it looks like it's going through here, so it can't go this way. So it looks like it's up here. And to check that out, let's do a couple of more points on the grid. What about if we have, say, x equals negative 1. Let's take this one right here. If x is negative 1 in the graph, what's y going to be? So let's put a negative 1 in. So we take this equation and put a negative 1 in. So x equals negative 1. So I'm going to put a negative 1 in the place of x here. So y equals negative 1 minus 2, negative 1 plus 3 minus 3. So I put a negative 1 in this equation and I solve that out. I get a negative 3 over 2 minus 3. So that gives me, that's negative 1.5, so that's a negative 4.5. So I get a negative 4.5. So a negative 1 gives me a negative 4.5. There's 4, there's 5, so let's estimate it to be right there. And we have it there. Notice we have a point here and here, so that means the graph is going towards the asymptote. There it is, and it's coming down here. And this one must be over here, so let's take it when this is a negative 3. Let's put a negative 4 in to see where this point is going to be, up here or down here. Just so negative 4. So x equals negative 4. So we're going to put a negative 4 in place of x here. So it's a negative 4 minus 2, negative 4 plus 3, minus 3. That's a negative 6, negative 1. So that's a 6 minus 3, which is 3. So negative 4 gives us a 3. Negative 4 gives us a 3. That's a 2. So there's a 3 there. So that's the point of negative 4 3. So it's going like this, and it's, there it is. So as x goes to negative infinity, y goes to negative 2. As x approaches negative 3 on the left, it goes to positive infinity. As x approaches negative 3 on the right, it goes to negative infinity. And as it moves, as x approaches, x goes to positive infinity, then y goes to negative 2. So that's reviewing again. Notice that the leading terms have degree of 1, they're linears, and so you can see the asymptote is the number in front. The way I solved it, I just did infinity over infinity to make it simple. Just a quick way that I do it. And again, if you like my video, click the like button, click the subscribe button, visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content. That's the content on my YouTube channel called Math Fully Explained. Thank you for viewing my video. Hope the video helped you. Bye-bye.